topic today was about interactive architecture. So how architecture itself is changing today because of digital technologies. The internet has changed our lives over the past 10, 20 years, but now the internet is entering physical space. The internet is becoming Internet of Things. It's creating a new hybrid dimension between bits and atoms, between the digital world and the physical world. And that dimension helps us really to sense space around ourselves, but also to have space around ourselves to respond to us. So architecture can become more and more dynamic. Architecture, we've seen in a beautiful way how it can interact with people because people move, but also architecture itself can become something that responds in a dynamic way. And that's actually the first project I did at MIT when I got there over 10 years ago. It was a project where we explore a surface that would become like a living surface. It was a surface made of sand. Then you had a laser scanner at the top, scanning that space in real time, and then sending back information to the surface. So they become like a living surface. But when we were doing the project at the Media Lab with Hiroshi Ishii, we had a dream. And the dream was, imagine one day when the surface itself of the sand could move by its own. Imagine one day when actually the computer itself could control that surface. So at the time we tried, but we didn't succeed. 10 years ago, you didn't have the same electronics you have today. You didn't have the same ability to really create control. So it was really exciting to see that just over a year ago, Hiroshi Ishii, with whom we were working at the time, managed to create a surface that does something like that. It becomes like a living surface. You see here that moves controlled dynamically. The person is not there. Actually, the person is quite far. But remotely, you can capture in 3 dimensions the person and then transmit that movement at a distance. As a kind of an experiment following what we did with Hiroshi, that was just a few weeks ago at Milan Design Week. We were asked by Vitra, a Swiss furniture house, to think about how spaces around ourselves are changing. A few years ago, you'd go home, you sit on a sofa, you'd open a newspaper, it was a printed newspaper, but today you're doing that in a different way, and we want more responsive spaces. So what we did here was actually something quite similar, by looking at the same idea when it becomes like a space around yourself where you can be, and you can enjoy different configurations. You have an element, this element is controllable, so it goes up and down. You can control it from your app, or you can control it just with your hands. You put the hand very close to it or quite high. And then you can actually create a space with different configurations around yourself in a dynamic, responsive way. And so, that's what we've been trying to explore in really over the past few years in different ways, in a lot of the things we've been doing, how spaces around ourselves can start responding to us in a different way. We were asked by, again recently by Cassina, another producer of furniture, to think about something that would become both like a traditional interactive element with the sofa. You go home, you read a newspaper on the sofa. Today you might go home and just tweet or read the same newspaper digitally on a tablet. So the idea to have something could be like a coffee table or a place to write or a place to engage friends. That's a very interesting idea, but no material exists to actually do something like that. When we proposed the idea, actually we had a couple of thoughts about how that could be done. And today we can do a lot of digital fabrication. It means if you look at this, we can do many elements such as this one, but slightly different. One slightly different from the other because they're all laser cut. In the past, in the 20th century, we had to do everything the same. Today, we can actually look at things that are slightly different from each other, and then when you combine them, you can create some kind of implicit programming in the way that they can take different configurations. So you see here the same piece. Each of them is slightly different, and so it allows you to take the configuration to the left or to the center or to the right. Here you can see how this became then the final thing, cutting each of them with a laser. The laser is the same thing that we use in most architecture schools these days, just slightly bigger. That's the same thing that's going to produce the final product. And then when you assemble them, each of them parametrically different than the other, you can create this shape, this material that basically responds to different configuration in a dynamic way. So it's almost like implicit programming. It's like this. You can open it up and take different shapes. We also experimented quite a bit with information on walls. In this project, we looked at something that's quite simple. It's like a projector, like the ones you have here all around. But on that projector, you have in front of it a rotating mirror controlled by a computer. The rotating mirror is such that basically from that point, you can actually project it 360 degrees around yourself. And so every surface potentially can become a living surface through digital information. So what you see here is actually the space where this surface can be a projection surface or another one. So the whole space was really built in a way that this could be off like this, or you turn it on and the architecture would be such, the co-visibility of surface would be such that every surface could become like a digitally responsive one. So it could be like this, but then if you turn on the projector, then everything could become like a living animated wall. The same thing can be also very important when we look at the energy consuming buildings. Now, if you think about it, today there's something quite absurd. We put a lot of energy to heat or cool empty spaces. If you think about the United States during the winter, we use a lot of energy in buildings. Think about our homes. During the day, we're not there. We're in our offices. They're empty, but we still heat them or cool them. And the same for our office buildings. During the night, they're empty, but still we heat them or cool them. And in this paper, we looked at a few years ago about where energy is consumed on the MIT campus and where people are. And what you find, as you see on this graph, is that there's no correlation whatsoever. There's no correlation, so we keep on heating or cooling spaces or using lights in spaces even when nobody's there. So we started thinking about, could we think about a different way of doing things? Imagine that heat or cool is actually following people, that we don't heat or cool the entire space, but just where people are. We started with this idea of local warming. Can we create this bubble of heat that actually follows people as they move through space? This was the first test we did at MIT. What you see there is the main entrance at MIT, 77 Massachusetts Avenue. People would step on the carpet, and then this bubble of heat would start following them. Some people freaked out, but most people loved it. So that was a test about, you could also customize your bubble. You could do at different temperatures based on your own preferences. And that led actually to this that you see here. It's two pictures, one next to the other, but it was at the past Venice Biennale, an art and architecture exhibition, where, as you see here, the false ceiling would supplement heating in a dynamic way for people around it. So you see here this bubble of heat that would follow people as they move under the space. And here's a little video of how that was made. So each of those elements creates a collimated beam. Through sensors would actually follow people as they move underneath. So that was the making of the exhibition at the Venice Biennale. And you see, here you wanted to make it quite visible, being an exhibition to show how it works. But you can imagine the same thing in the future that becomes slightly integrated in a false ceiling. Just imagine infrared LEDs that supplement heating or cooling in buildings just where we need it. So again, an architecture becomes almost alive that responds to us in a dynamic way. When it turns on, you see this bubble of heat that follows people as they move here in a visible way, but you could make it really almost invisible. And I want to finish with another project that we did, in this case for the World Expo, that was a few years ago. The theme of the expo was water. So the mayor asked us, could we do a building totally made of water? This was the entrance of the international exhibition. No doors or windows. This water would be digitally controlled, so you could write or show images or text. Inside, all the walls would expand and shrink based on how many people you have in the space. It was the main entrance. Then the bridge was a Zaha Hadid bridge that would lead to the exhibition. If there was too much wind, you could lower the roof to minimize splashing. And then at the end of the day, you could actually close the building and the whole architecture would disappear, hopefully without anybody underneath. Well, we had sensors for that as well. That was the building. We had a lot of fun doing it and doing the video. We were not sure they would actually build it. Then what happened is that just 6 months before the expo, Time magazine put it in the list of the best invention of the year. We had to build it very, very quickly. That was the picture before the opening. I like this picture because you see that guy had a trolley, was going to the station, but then stopped there for 5 minutes to say, what the hell is happening here? Here it was myself interacting with the water. You see projections on the water, so the digital pixels and the physical pixel overlap on each other. So the building is made of thousands of sensors that detect people as they move, as they approach it. One night, all of this is controlled by a computer. The computer crashed, and the building stopped responding to people. And that night we were terrified because the building would keep on doing its own crazy things, and cuts and holes and images and text and pattern, but without responding to people anymore. However, that night was one of the most fun nights ever. That night, thousands of kids from all over the city went to the building to play a new game. Not anymore a building that opens up when you approach it, but a building that you need to engage like this. It is a video, it's small because it's a low-res video taken from YouTube. You find a lot of them. And for us, it was an important lesson because as architects, as engineers, we always think that we know how people will use the stuff we design. But then reality, and especially human reality, is always a surprise. In this case, it was a good surprise. Thank you.